Good morning. It's August the 10th, coming to you live from the office break room. And today we're going to be moving on, talking about composite functions. In particular, we're going to be looking at how to evaluate a composite function if it's written as an ordered pair, if the function is expressed as an ordered pair, as tables, as graph, or as expressions. So let's get started. First of all, what is a composite function? All right, a composite function are functions that are formed from two functions in which the output of one, or the result, is used as the input of the other. So a number goes into the function, comes out, then that number becomes the input of the second function. That's how you do composite functions. Okay, the notation for composites look like this. And we read that as f of g of x. Okay, the g of x, this is known as the inner function, and the f is known as the outer function. Now that's important because the order in which you do these matters. Another way of writing it is using this open circle here. That also means this is the symbol for composite functions. And we read it the same way. Okay, f is composed with g of x. But typically I read it just like the one over here, f of g of x. I read them both like this. Okay, so the important thing to remember is whatever the inner function is, the output from the inner function becomes the input for the outer function. So let's take a look at an example if you had a function expressed as a set of ordered pairs. All right, so we've got two functions here. And the first one's asking us to find f of g of 5. So remember, that's how we'd read that. F of g of 5. All right, now, what you're going to do is whatever you actually evaluate a function working from right to left. This is the inner function. So your input is 5. So I'm going to put a 5 right there. Okay, then it's going to go through the G machine. Well, when 5 goes through the G machine, when the input is 5, its output is 7. So this is what we just did. This part right here becomes a 7. And if I was writing it using function notation, I'm now going to be figuring out what's f of 7. Okay, so this now is the input for function f. So when the input is 7, the corresponding output is 3. So this is equal to 3. All right, f of g of 3. So g is your inner function, so that one's going to go first. 3 is my input. So when 3 is the input on function g, that 3 gets turned into a 5. It becomes the output. Now that 5 becomes the input for function f. There's the input of 5, and its output is 3. So notation-wise, the way that we would write this is our first step would be find g of 3. Okay, when I got g of 3, this right here became a 5, and then the output associated with 5 for function f is 3. All right, now, what I did on the third one here is I switched the order. So now f is the inner function. So function f is there, function g is here. My input is 5. Okay, when I put 5 into f, when the input is 5, the output is 3. So I'm going to put a 3 right here. So this part becomes a 3. So I take that out and I replace it with 3. And then I go up here and I figure out if 3 is the input for G, then its output is 5. And now our last one, it's G of 5. So now what you're going to be doing is 5 is your input. It's going to go through function G. It's going to come out, then you're going to put it back in function G. So if I put 5 in for G, I get a 7. 5 goes in, 7 comes out, so this becomes G of 7. That whole thing becomes a 7. Remember, this is the output when the input is 5. Output when input is 5. That's what G of 5 represents. Okay, so then I go up here and I look, well, if the input is now 7, the output would be 9. So that's how you evaluate composite functions if you're dealing with ordered pairs. Okay, now a table is just the same thing, because a table is really just ordered pairs. Okay, these are your x coordinates, and then these are the y coordinates for f, for g, and for h. Okay, so our first one is f of h of 0. So 0 is our input. It goes into h. So what comes out is -1. Now -1 goes into function f, and what comes out is a 2. So we kind of did this. It went here, and then we took that, and it went right there, and we got 2. And the way we'd express that is f, okay, h of 0 was -1, and then f of -1 was equal to 2. Okay, f of g of 0. So g is the inner function. F is the outer function. Our original input is 0. Okay, so I put 0 in, and for g, it creates a -1. So this would become f of -1. And that -1 becomes the input of f. So that's what happened. And we end up with 2 again. Now we've got a composite of 3 functions. You just keep going, okay? So this would be 0 is your input. It's first going to go into function f. Then that result is going to go into function g, because I'm reading from the inside to the outside. Then it's going to go into function g, and then finally it's going to go into function h. So let's see, 0 goes into f, and out comes a 0. So I'm going to replace this part with a 0. Now 0 goes into g, and I get a -1. So this gets replaced with a -1. That's the output from G when the input is 0. And now I'm going to go to -1 and figure out what H is, which in this case would give me 1. And that's my solution. All right? Okay, last one. These two notations here are the same. Okay, this is 3-function composition, and so's this. It's just written differently in using the composition symbol. So 0 is my input. Okay, and then the order in which I'm going to evaluate this is I'm going to do function G, function H, function F. Okay, so 0 goes in, and I put it into G, out comes a -1. So I would write this as F, H, and this became -1. Okay, now I put -1 into H, and it becomes a 1. So H of -1 here becomes 1. So now I'm going to evaluate if 1 is the input into F, what's the output? Another 1. So that answer is 1. Okay, now when you're doing it on a graph, it's the same. You're doing the same thing. You're just reading the graph first. All right, so our input is 4. And then we're going to do it in function G, and then we're going to put it in that output into function F. All right, so I go to x equals 4. Let's change the color here. X equals 4. And it intersects the graph at y equals 4. All right, so the first part of this graph, if I was writing out the notation here, I'd write F, G of 4. Those two things are identical. All right, G of 4 was also a 4, so I take out the notation G of 4 and I put a 4 in. Now that 4 becomes the x-coordinate over here on graph F. So there's 4. So I go up. That intersects the graph. So I go over. And the output is 5. So F of 4 is equal to 5. All right, G of F of -3. So my order is going to be -3, F, whatever that is, and then G. So notation-wise, if you were writing it out, you'd write G of F of -3. So I'm going to go to -3 on the x-axis, and its output is the y-coordinate 0. So this gets replaced with a 0. And now I'm going to evaluate G of 0. So now 0 goes into G. 0 is the input, -4 is the output. And so G of 0 is -4, and that is my solution. All right, G of -2, F of G of -2. Okay, so another way of writing this would be F composition G -2. It's just a different way. All right, so I'm going to start with an input of -2. It's going to go into G, and then whatever that is, it's then going to go into F. So here's G, I go to -2. There's my point. Go over, and the output is 3 for -2. So I put a 3 right there. So now this is going to be F of 3. Took this whole notation out and I just replaced it with 3. Now 3 is the input over here. So we draw a vertical line, crosses, and it creates an output of 4. So now this all gets replaced with a 4. Okay, now you got a function going into itself. So our input is 2. And again, this would be the same as writing F composition symbol -2. Okay, so it's going to go into F. I'm going to get an answer. So when x is equal to -2, the y coordinate is 0. So 0 goes right there. And then I take that 0 and it becomes my input. So f of -2 is 0. And now when x is equal to 0, the corresponding y coordinate is 1. So this is equal to 1. Okay, now we have 3 functions. So if we were writing this out using the composition symbol, we'd have this would be GOF, G of F of G. So 0 is our input. It's going to go through G. Then that number becomes the input for F. And then the result of that becomes the input for G again. All right, so when x is 0, okay, G is, whoops. So when f is, when x is 0, G of 0 is -4. Okay, so this now would become G F. And now I'm going to take out G as 0 and replace it with -4. Okay, now we're going to use -4 as our input. Okay, that's right here. And its y coordinate is -3. So that's the point -4, -3. So the output is -3. So this now is going to be G of -3. So I took this whole thing out and put -3 in. Now I go back to G. -3, there it is. Its y coordinate would be -1. When -3 is the input, -1 is the output. So my final answer is -1. All right, now if you have composites and their functions are written as expressions, Okay, well, we can use our same model. All right, so we're going to do first g, this is f of g of negative 3. So negative 3 is our input. It's going to go into g, and then whatever that output, it's going to go into f. All right, so I'm going to first do g of negative 3. So I go up to my function g, and I'm going to plug a negative 3 in. And I get negative 3 squared minus 4. So that's 9 minus 4, which is 5. Okay, so the output is going to be 5. So again, this means what's the output when x is negative 3? When the input's negative 3, the output is 5. Now take that 5 and plug it into function f. So now we'd have f of 5 would be 5 minus 2 times 5, that's 10, so that would be negative 5. And that would be my answer, negative 5. Okay, now if we switch the order, does it matter? Okay, so all I did here was, instead of going into G first, we're going to put it into F, and then put it into G. Okay, so we'll first do, we got G, F, negative 3. So we start with negative 3, and I'm going to plug it into f. So f is 5 minus 2 times negative 3. That's negative 6. 5 minus negative 6 is 5 plus 6, so that's 11. And then I'm going to take that 11. So this would become... let's see, let me get my face out of the way. Okay, this would be G11. So when I put 11 into G, I get 11 squared minus 4. So that's 121. Take away 4, which is 117. And that would be my output. And that's how we evaluate functions. Tomorrow we'll build the functions. Okay, what would the equations be for composite functions? Today was evaluate the functions. Just so that you get an idea that the input to the first function creates an output. That output then becomes the input of the second function. And that's how you evaluate composite functions. All right, so that's all. Your assignment that goes with this is Math Excel 4, Composite Functions, Day 1. I'll see you next time.